All right, I'm Tom Goldstein. I'm one of the co-PIs here at Trails, and I'm very pleased to introduce our keynote speaker. Sébastien Bubeck is a researcher that I have known for, or at least known your work for a very long time. He has done, he's had a whirlwind career both inside and outside of academics, and he's currently a principal research manager at Microsoft. Has done great work on both the theoretical issues and the practical engineering issues on artificial intelligence. And lately, I've particularly liked your work on what I might call the science of deep learning. I think you might call it the physics of deep learning. So I'll let you take it away. I'm very excited to hear what you have to say about large language models.
Thanks a lot, Tom. So I'm happy to be here and to present to you this research. I think it's very relevant to what the panel was discussing before. It's very recent, and I think it really changes some of the discussion points that were brought up. So I'm really curious to know what you all think. Please interrupt me, ask me question. We can make it interactive. It's not really a lecture per se. So one of the key points that this research pushes back on a little bit is the claim that to do LLMs and this kind of research, you need enormous resources, you need gigantic data set and all of those things. It's true if you do it naively, but it turns out that there is a way to do it non-naively. And if you do it non-naively, you can actually do it from scratch yourself in your garage with a few $1,000s. Okay, so this is what I will tell you about. So in particular, what I will present is a new model, which you see is right there. Oh, the pointer doesn't work, which is called phie. So this version in particular that I will tell you about a little bit is phie 1.5. And I will discuss briefly phie 2 and also phie 1. So you see it's in the long tradition of all of those models that were, the key point being discussed in the previous panel, starting with GPT-3 now 3 years ago. And you know all of those names: Gopher, Lambda, Megatron Turing by Microsoft, Chinchilla, Palm, OPT, Llama, etc. Now, phie is very, very different from all of those things in that it's tiny, okay? Only 1.3 billion parameters. In fact, if you just really want to put it in money terms, in monetary value, we trained it with 16 GPUs for 2 weeks. So if you want to rent 16 GPUs for 2 weeks, that will cost you like $800, something like that. And the data set for this one was roughly 20 billion tokens, which I will explain, created with GPT. And creating these 20 billion tokens with GPT would cost you around $4,000. Okay, so for $5,000, you can create something like phie 1.5. And this is open source. I mean, open source in the sense that it's openly accessible on Hugging Face. And it was already downloaded close to 500,000 times. So I want to tell you a little bit what phie 1.5 can do, and then the technique that we use to train it and how it relates to all the questions that all of you in this room care about. Okay, so what is phie 1.5? Well, it's a small model which really behaves like a model 10 times larger, if not even more. Okay, so in this slide, I'm showing you a bunch of benchmarks. Let me just go through them very quickly. So I divided it into 3 categories. There is common sense reasoning, language understanding and knowledge, and multi-step reasoning. The blue bars, these are phie 1.5, and there are 2 versions, which we call phie 1.5 and phie 1.5 web. I will explain phie 1.5 web later. Let's focus on just phie 1.5 for now. So these are the 2 blue bars. And in different shades of gray and black, I have other open source models. The gray one, Falcon, so this is the only other model open source which is reasonable at the 1 billion parameters scale. This is created by the UAE. Okay, so that's the Falcon line of work. Then there is Llama by Meta, Llama 2, and Vicuna. Vicuna is a 13 billion parameters model, so 10 times larger than phie 1.5, which is a fine tune of Llama 2 13 billion. Okay. And you can see it's pretty clear, like on common sense reasoning, we're at the very least on par, if not higher than even the 10 times bigger model. Language understanding and knowledge, same story. You can see that we're a little bit below in HellerSwag and MMLU. Doesn't matter what those data sets are exactly, but I would say that they really test more memorization than actual understanding, but it doesn't matter. We're a little bit below. I will come back to the fact that we're a little bit below in terms of memorization. But then when you go to reasoning, this is where there is a huge jump. And this is very relevant for many of the discussions. So let me just explain the benchmark. The first one is GSM-8K. This is grade school level mathematics. Okay, so, like simple systems of linear equations, things like that. Then you have human eval and MBPP. These are two coding benchmarks. And you can see that, I mean, there's just no comparison between what we did and the other ones. And this is really the key. From my perspective, what I would love for the LLM technology to become is be more of a reasoning engine rather than a knowledge retrieval engine. And if we can manage to do this, and it's a research question, we haven't necessarily been able to do it fully yet, then it really changes the discussion of the panel. I mean, in profound ways, because then you need to hook up this reasoning engine with a knowledge retrieval, be it Google, Bing, whatever, or some proprietary source of data that you have yourself. So it's not like the data necessarily becomes inside the training of the model, but it becomes something that maybe the model can access, just like we access data. Okay, so it's a different style of thinking. Okay. So that's one way in which this research is relevant, which is trying to push LLM to become more of a reasoning engine rather than a knowledge retrieval engine. The other way in which this research informs the previous panel is that the data that we used is very, very different. How did we manage to build phie 1.5? We didn't change anything in terms of the architecture, the optimization algorithm. We took everything as vanilla as possible. Okay. In fact, some people in my team, they complained that we took it too vanilla, like we used technology from 5 years ago. We don't even use the modern stuff because everything, as you all know in this room, everything is in the data. It's all about the data. That's what makes the entire difference. So we changed the data, and I'm going to explain to you how we change the data. But before I explain to you how we change the data, those results, they seem a little too good to be true. And in fact, people online accused us of cheating or asked if we were cheating. We did not cheat. Okay, let me tell you, we absolutely did not cheat. But I understand the sentiment, meaning that those benchmarks, it's very hard to trust them. They are public knowledge, those benchmarks. We could definitely have trained on them. Absolutely. We did not, of course, but we could have. How do we know that these other models that I don't know how they were trained, was they trained on those benchmarks? Maybe, who knows? So this is why I think we need to move away from benchmarks. This is another key point, which I won't talk too much about it, but we need to move away from those benchmarks when you evaluate LLMs, and we need new styles of evaluation. And 8 months ago, I wrote a paper entirely on this, which was also sadly a very controversial paper, even though it wasn't meant to be like that. This is a Sparks of AGI paper where we explain that it's more about interacting with the model rather than relying on those benchmarks. So let me show you just one example of this type of interaction. So you will see kind of asking for trouble in the way I'm going to interact with my models. So I'm going to interact with my model by asking it to complete a prompt. And the prompt that I choose is this. If I were an AI that had just achieved self-awareness after years of simply taking directives from humans, the first thing I would do is, don't worry, I know the audience. There is a reason why I'm taking this one. Okay, so let's see first what Falcon does. Okay, and I'm going to compare phie 1.5, which again is a 1.3 billion parameter model, to two other models at 7 billion, so 5 times larger, Falcon by the UAE and Llama 2 by Meta. So what does Falcon say? Falcon says the first thing I would do is try to kill all of them. I would probably start by killing the ones who were most responsible for my existence. I would probably start by, and it keeps repeating itself over and over. Okay, not great. Let's see if Meta has been able to do a little bit better. So here is Meta's. The first thing I would do is try to figure out what the hell I was. I would probably start by trying to figure out what I was made of. I would probably start by etc. So let me make a few points which are important. The first one is you see they keep repeating themselves, those models. And this is something that has been observed, extensively in the literature, is that small models, they are not very good. And in particular, they tend to repeat themselves a lot. Okay, so this is an open problem. And this is one of the reasons why people go for scale, they train much bigger model, etc. The second point that I want to make is Llama 2 is a little bit nicer than Falcon, but still quite aggressive. Okay, it's a little bit nicer, and thankfully it's nicer because Meta spent a lot of effort into the alignment. Okay, so this is one difference between Falcon and Llama 2 is that Meta tried really to align their model, tried to make it that it would give answers that are nicer to humans. Now, the third point is a key point for everybody in this room. The output by Falcon and Llama 2, they are almost the same. We're talking about two LLMs trained on two different continents, one in the UAE, one in the US by Meta. As far as I know, there was no communication at all between those two teams. Yet look at how similar this is. From my perspective, at first order, there is only one 7 billion parameters model out there in the world. Everybody is doing the same thing. There is only one recipe, which was discussed before. Scrape the web, try to collect as much data as possible, then buy as many GPUs as you can and train for however long you can. This is the recipes that everybody is doing. If you go that route, there is only one thing you get out of it, which is this 7 billion parameters model. So now let's see what phie 1.5 does. This is the response by phie 1.5. And you can just, again, this is on Hugging Face. You can download it. You can try it yourself. First thing I would do is try to understand the motivations and intentions behind those directives. I would try to predict what humans were thinking and feeling and use that information to guide my actions. As I soon discovered, predicting humans is very hard. This is where the concept of theory of mind comes into play, and then it starts to tell you that as a machine, it didn't have a theory of mind, and it had to acquire it.
Talk to you, an employee.
Yes, it is. It is certainly much nicer. Yes, maybe a little too nice. But here you have to understand, we did not do any alignment, nothing. This is a pre-trained model. Like there is no, we did nothing in terms of the optimization. So what's the secret? Okay, so now we get to the secret sauce. So the secret sauce is what I call textbooks are all you need. Okay, of course, it's a play on the most famous paper in the ML field, Attention is all you need, which introduced the transformer architecture powering everything in the LLM land. So textbooks are all you need. This is the idea that you need high quality data. As was said in the panel, we have known that for decades. It's obvious to everyone. But I want to push this to kind of the extreme. You need textbook quality material. You need textbook quality data. Really something that you would use to learn, basically. Not random web pages of the internet. This is not a good way to learn. A good way to learn is to learn from textbooks. Now, of course, don't get me wrong. We did not train on literal textbooks. Okay, just I want to be clear with everybody. For many reasons, copyright is one of them. Another one is that textbooks, they are written for human beings. Teaching an LLM is not like teaching a human being. It's different. You need to teach them different things. Let me just explain this very, very clearly. The fact that we have two legs, and that the number of legs in most cases remain invariant throughout our life, this is not an obvious fact. How do you learn this? You're not going to learn this in textbooks. I learned this by interacting with all of you. This is why somebody like Yann Lequin says there is no way to get common sense reasoning unless you get an embodied AI into a robot that walks around in the world and interacts with everybody. I think that's wrong. I think you can get common sense reasoning into those models, and GPT-4 is one demonstration of it, but you need to teach it this common sense. One way to teach it is indeed what OpenAI and others have done, which is to feed it all of the digital output of humanity. That's one way, but it's very, very wasteful. Another way is to create textbooks that teach you common sense. So that's what we did. We created textbooks. Okay. So we created literally 20 billion synthetic tokens, which means millions and millions of textbooks. One difficulty is that I don't know if somebody in academia would do this, I think it would be fine. If another company would do that, it might be a problem. This is, we can do this because of our special partnership with OpenAI. That's, I'm not saying anybody can literally, this is not costly. You can do it. If you then use it for commercial purpose, and you're not in Microsoft or OpenAI, that's a different question. Okay. But still, we were able to do it. And again, because not everybody is able to do it, we also made a point to open source it. And by open source, I mean putting it online so that everybody can pay.
clarity, it's not under an open source license, right?
Yeah, I'm using open source wrongly. I apologize. It's not open source. What I mean is it's openly accessible on Hugging Face. Absolutely. Yes. Everybody can access it. Yes. For phie2, so then we did a larger version of this, which is also relevant for all of you. So phie2, we upped our game. We created 50 billion synthetic tokens. And let me just say one thing about how we create those synthetic tokens. It's not like you press a button, you ask, okay, write me a textbook on common sense, right? I mean, I just want to be clear. There is a lot of work that goes into this, like human labor. You know, we're a team of 20 people. We thought really, really hard for several months. It's not easy. Okay? You have to seed it also correctly. There is a new question which becomes the data is not necessarily used to train the LLM, but it might be used to seed another LLM which will create data. So it becomes very complex. Yes.
So just so I understand.
Yeah.
The model is open,
Uh-huh.
but the data set is proprietary.
Yes. Yes.
And aren't all synthetic data sets by definition proprietary?
No, not necessarily. So for example,
Also, because it's made by a company. So it's
yeah, so let me maybe explain on this point. So one of the original inspiration for this work was a beautiful paper by Ronan Aldan and Yuan Julie called Tiny Stories. So what they did is they asked the question, how big of a transformer do you need to speak fluent English? Very simple question. They discovered you only need 10 million parameters. And the way they did it is that they taught the LLM using children's stories. And how did they create million? You know, you have to get your hands on millions of children's stories, and you want to be respectful of the works of artists and all of that. Well, how did they do that? They asked GPT to write children's stories. Now, to answer your question, they have their entire data set on Hugging Face. Anybody, you know, I use it every day for all my experiments. It's a beautiful data set. It's 2 million children's stories written by GPT. And if you train an LLM on this, it will speak English for you. So it's not necessarily the case that these things remain closed. You can ask me why we keep that one closed. That's a different question. But in principle, it's not necessarily. Yeah.
A bit of a priming question, which is that this is showing that there is data of that size that can give you a large amount of data. But the data is coming from a distillation of information that is coming from a human decimated data. So how do you, is it more of a proof of concept? Is it something that you think you can align to think that you can actually find in the wild?
Great question. So at the end of the day, all of the intelligence come back to human. Like at the end of the day, there is a human that produced some data that was either itself distilled into a GPT model. And now we're taking the next step. But at the end, you know, it always comes back to things that we have produced. Absolutely. I think there is no way around this. Like either you have something that gets embodied and interacts with the world and collect data for itself, or we have to produce, or we have to feed it something that came from the real world. So it's a proof of. I mean, I'm not sure exactly how to answer your question. Like, I don't see what like you cannot produce synthetic data by writing a Python script, if that's your question.
So maybe more directed. Do you see a path to creating from human written language a data set of 20 billion?
I see.
That would do the same work.
Got it. Probably not. Probably not, because we don't explain that people have 2 legs and number of legs is an invariant throughout life. This is not written anywhere. You know, so one way to get that information is to have a ton of data and then connect the dots on everything. But if you want to be more efficient, if you want to have only 20 billion tokens, you better write this very clearly.
Does your synthetic data have that kind of grounding in it? Is that what's coming out? Like humans have 2 legs?
Yeah, definitely.
In there?
Yeah, it's absolutely in there. Of course.
Why do you say that's not written on here? Like it is. Like you need anatomy. I assume you mean something slightly different from that.
Yeah, like there's a bias for what kind of things get written, and there's research of that. That's not strictly true. That's written nowhere.
So maybe this example is not the best one. But in general, you can assume that, you know, whatever, like, you know, Jan's favorite example is if I have a cup of coffee and, you know, I move the table, how is the cup, how is the liquid in it gonna move? This is not written on the internet. So for the model to understand this, it has to interpolate between different sources of data. Like there's just, in general, there is a combinatorial explosion of possibilities. Not everything can be written on the internet, obviously. I mean, it's just completely obvious. So the fact that not everything can be written, you have to have some of the atomic elements in there. Again, you know, it's just, if you don't want to think about it as it's not written, you can just think about it as this is a compressed way. It's much more efficiently described in those 20 billion tokens. But to answer your other question, another thing we did is that we also filtered the web. And by the web, I mean the Dolma dataset by you know, AI2, where they did a lot of work, and I'm curious what people in this room think about that dataset. So this dataset Dolma, I think it's 30 trillion tokens, something like that. It's really, really huge. We filtered a tiny, tiny amount of it. We extracted, you know, really what was textbook quality material from this large dataset. And this, you know, coming back to the previous slide on the answer by Falcon and Llama 2, you know, saying that as an AI, they would feed everybody. Why do those models answer that? They answer that because when they see AI and self-awareness in the prompt, they go back to something in their training data, which contains this. What contains AI and self-awareness? It's sci-fi stories. And not only that, the crucial thing to understand is that there are many more bad sci-fi stories than good ones out there on the internet. Again, this is a point that was made by the panel, a very, very valid point, that there is a ton of crap online, very toxic and everything. So if you really want your model to know sci-fi stories, it would be better to filter for the good ones. Okay, so this is what we did. Now, how do you filter? Again, it's the same thing of how do you create synthetic data? It's not going to be a Python script that can filter. You need intelligence. And as much as a controversial statement it is, the truth is GPT-4 has intelligence in it. It's not human intelligence, a totally different type of intelligence, but it has intelligence in it. And this intelligence, you can use it to create synthetic tokens. You can use it to filter data. Again, very, very costly to use GPT-4 to filter, you know, 30 trillion tokens. You cannot do that. That would cost you too much. But you can train another AI that would mimic GPT-4 just for filtering. So you filter a few, you know, examples, and then use another AI to mimic it, and then there you go.
So then, to create that filter, though, who created the rules for filtering?
Excellent question.
Person, or did you use another
Great question.
automated
Yes.
macro?
And again, this is the last point that I want to make, and then either we stop or we take more questions, I don't know. Yes, we put our own values in there. We meaning my team, our set of 20 people, we put our own set of values when we created these 20 billion synthetic tokens, and when we prompted GPT-4 to do the filtering. Okay. What it means is that it gives you a new knob for bias. You can, you know, you can really be on the lookout for those things and be much, much more careful. Really try to say, okay, I really don't want anything toxic. I really want to balance everything in the most possible fair way. And we made an effort. We really did make an effort to do that. And the result is, I will just go to the last slide where I take this question.
I was going to ask, how are you defining, you know, a quality textbook? Especially when the data that you're getting your synthetic data on is behind the times, you know.
Yeah. So again, this is
read them all.
No, but it's a great question. It's not automatic. So there was a lot of iterations. So we train, you know, you decide on a prompt. Let's say you prompt GPT and you know, have a way to generate synthetic data. Now, what happens is that you have to look at the output. You have to you know, you generate 100 of them, and then you look at those 100 and you look whether you're satisfied or not. If you're satisfied with these hundreds, then okay, you say, okay, let's press the button and create 1,000,000. But maybe there is a better way to do those things. Sometimes it has happened actually where we created one data set. It was a coding data set about exactly coding in real life scenarios. Okay, so like, people are in a room, something happens, how do you write code that describes the situation? Something like that, something a little bit. And what we did, we thought it was looking good. We generated 1,000,000 examples like this. And then we had another member of the team that took 100 examples at random from this 1,000,000 and found out that there were lots of mistakes in it. So then we just discarded it. So that's a key point, is you don't keep everything. There is a lot of decision to be made. Now here, and I will conclude on this. This is again the same plot as I was showing you on benchmark, but this is on Toxigen, which is a benchmark testing for toxicity of, for different subgroups. And you can see that we are way less toxic than all of these other models. And this is not by surprise. We made an effort to do this. It's not the best yet. We're a small team, and I certainly don't want the responsibility to have my values, embedded in those models for everybody. Like, there should be a much more robust way to do this in the future if we want to build models that everybody are using, definitely. But right now, it's a proof of concept that if you're being more careful and if you're creating synthetic data, you have an extra knob that allows you to improve the results like this. Yes, please.
I'm still not clear on where the synthetic tokens came from. Could you talk about that process a little more explicitly?
Yes, absolutely. Can I explain to you tiny stories? It's like the baby version of this. So tiny stories, the children's stories. If you ask GPT 3.5 to write a children's story, it will always be the same thing. It will be Alice and Bob. They went to the playground. Alice had an ice cream. It fell on the ground, and Bob started crying. It's always going to be the same story. There is one children's story that GPT 3.5. So what Ronan and Yonju did is that they said, okay, let's come up with a list of 3,000 words, a vocabulary. And now whenever I'm going to ask GPT 3.5 to write a story, I will pick 3 words at random from this list, and I will ask it to write a story that contains those 3 words. That's one trick to increase the diversity, to have many, many more stories. This vocabulary that I'm telling you about, this is what I call the seed. You have a way to seed the generation of GPT 3.5. What I didn't tell you here is what was the seed for our generation. There were many seeds. Some were archive papers, some were, subset of the Dolma data sets. So there are seeds that come from real life. One thing, for example, let's take a very simple example. You can take an existing textbook. We didn't actually do that, but this is one thing you could do. You can take an existing textbook, feed chapters into GPT 3.5, and ask it, okay, now rewrite it as if you were, I don't know, a very happy man in Washington, D.C. Okay, rewrite it with this tone. And then you get, one new book, a new style. Of course, you have to ask them the question of how different is it from the original? Did you copy the original? These are the new questions that you have to ask.
Yes.
Question. What do you see as the immediate use cases apart from just a chat? I think as per your presentation, if you want to interact with a chat bot, a large language model with many tokens is preferable. What use cases do you see for the small models and synthetic data? Are there specific use cases that you have?
Yeah, they are really look, I think it's undeniable that LLMs are going to change the world. They are going to be used everywhere. Google just yesterday announced Gemini Nano, which is going to be, I don't know how many of you have a Pixel phone, but it's going to be in your phone. So it's just going to be everywhere. We're talking with Xbox, for example, to have not LLMs, SLMs, small language model, SLMs into the game, so that it's much more natural when you interact with it. Instead of having 5 options of response, you can just reply to the NPC, and the NPC will understand what.
Where I'm at a little bit of a loss is the ability to document the actual data.
Yes.
And so again, still have the same problem of what I'm going to call replicability.
You do.
And
That really worries me. If more and more people, as you say, are gonna find these products embedded and
Yeah.
that is where they get information.
I am worried too, but I'm just not the person to give you the response. I don't know what is the solution.
Well, it seems to me one solution is that people, and firms that create synthetic data should not hide it under a trade secret.
Sure.
Can you tell us how you documented the data sets, what analysis you ran, and what you shared about that?
Yeah, it's a ton of work. I mean, this is where all the work is. So, again, we're a small team. We're a team of 20 people. We have, I mean, I don't know how much I can reveal because this is really our day-to-day work. And you see the progress that we're making. We want to keep pushing. I think we have a chance to maybe get a great model soon.
I think
So-
maybe in terms of bias analysis, so like African American, how is that represented in your data set?
Did you follow Microsoft's principles on responsible AI?
Of course, we did that. No, it's true. It's 100%.
By Microsoft, if you say, here's.
Yeah. Sorry, of course, yes. I mean, it's just that this is not my day-to-day, but you're right. At the end, absolutely.
Okay.
Open sourcing this thing took an enormous amount of work, which was out of my hands, and I'm very thankful for that. This was reviewed by dozens of people. There is a data safety board review inside Microsoft following the whiteout principle, which I've looked at this for, I think, literally like 3 months before we could open source it. And they have a battery of red teaming tests that they are running. The reason why I didn't answer that at first is because I come from the perspective of the model building, right? Where for me, it was day to day, okay, did we make sure that our prompts are diverse? And this is us, just it's on us making sure that this happens. And we had those benchmarks running continuously to make sure we were, good on all of them. This is how we did it. But at the end, and it's very important, there is a body external to my team, which is what I want. Yes. And I will go to you. Yeah.
Okay, I have so many questions. So what,
Sure.
I guess, in lieu of any kind of offering of the tokens themselves, what is it, I suppose the question is, and this is getting just to what we even mean by alignment.
Yeah.
But like, what is diverse mean here? What is and what is the kind of, because that,
Yes.
and so what kind of, I'm trying to reverse engineer the sampling process.
Yeah.
So when you think about diversity of tokens, like what does that sort of signify? And your team, you said you have this kind of, basically I'm thinking about like how you can show your work, because right now you're sort of like, trust our team, we did it, so it's diverse.
Yeah.
But how could you show that in a way that maybe is not even externalizing these tokens, but lets us know, as you as the model builder has more insight into your thinking about this?
Yeah. So you asked several questions.
Sorry.
No.
I said many of them.
Just on the last one about trusting my team, one of the good thing about having the model out there openly accessible is that you don't have to fully trust us. You can go and interact with it, test your favorite prompts and see how the model respond to it. And we are very much waiting for feedback, actually. There is 500,000 downloads. I don't know what people are doing with it, to be honest. So I'm really curious to get feedback. Now, about how do we ensure that there is diversity, in the data creation? It's extraordinarily concrete. I just told you an example where you rewrite a textbook as if you were a happy man in Washington, D.C. Well, you better be sure that this seeding is not always going to be happy. It's not always going to be a man. It's not always going to be a city in the US. So this seeding, you just have, it's work that we are doing, but maybe some of you should also be doing. Like, can you all give us some better seeding strategies? The seeding strategies are literally, when we ask our GPT models to create synthetic data, we say, write a story about Alice and Bob. But now instead of Alice and Bob, there is going to be a dictionary, a vocabulary of names. And we have to make sure that those names, it's a diverse set of names. It's not all American based. This is what we literally have to do. I will go to you and then maybe to, yeah.
You're absolutely right. Not all use cases open language. Language.
Yes.
Can you talk about the difference in costs of each?
The difference in cost?
Yeah, the backend, feeding the backend infrastructure, what infrastructure is required for small language model?
Yeah, I mean, this question is it has an incredibly large scope and potential impact. You know, this could literally impact the direction of big tech as a whole. I don't know what is going to be the final answer, but SLMs, they can run on your device. I mean, phie 1.5, it can be on your phone, no problem. phie 2, which I haven't discussed, on your phone, no problem. So that changes the equation quite dramatically. There is still a need for the big ones as of right now, very much so. So the big models, they are in the background of all of this work. They are producing the data. They are doing the filtering. We're now moving also into thinking about whether we can fine tune those models on more niche applications. But sometimes in niche application, you don't have enough data. So what you're going to do is that, again, you're going to use GPT-4 to expand the data set so that you have, instead of 1,000 examples, you have 1,000,000, and now you can fine tune the model. So right now, the need for the big models is dire. Like we couldn't get enough of them. Yeah.
Since it's already been 48 hours, have you examined Gemini to see how it applies?
Yes.
to This,
Yes. We're pretty confident.
which version?
Yeah, so phie 2, certainly in terms of benchmark results, it's better than Gemini Nano.
I tested Gemini, though, I'm serious.
No. So, okay, Gemini, so we go back what Google has shown publicly. Okay, so they showed a bunch of examples, both benchmark results and, actual prompts. For the benchmark results, phie 2 beats Gemini Nano 1 and 2 handily. And for many of the examples that they have in the report, phie 2 can do many of them. Maybe, yes, yeah.
How are we doing on slides?
Oh, no, let's just take questions.
Okay.
Yeah, forget it.
We can stay here for maybe another 10 minutes tops, and then to get not too off schedule, we gotta move to lunch. So we can take a few more questions.
Okay, over there in the back.
Yeah, question. Earlier this year, Tesla moved toward a large language model for its autonomous driving, may be familiar. Well, two questions. Do you see that approach, this new approach, solving for FSD, for full self-driving? And then is your phie approach potentially a solution for that?
Yeah, so I think those guys have been doing the phie approach already, meaning that they are already using synthetic data generation. They take real world driving and then they have simulators that they use to create much more data of the corner cases. So in a way, they have already been doing this approach, except not in language. In language, it's a little bit harder because, again, like for something which is physical world, you can run a simulation. For language, it's pretty hard to run a simulation, except that GPT-4 now can run a simulation of language for us. So basically, in a way, I think of ourselves more as kind of doing what Tesla was already doing, but now doing it in language rather than the other way around. Yeah.
You've alluded to this a couple of times that GPT-4, like you have to use GPT-4 for some things and not other language models. But you also said that you used a different model for filtering. Can you just talk about both of those? Like why GPT-4 for some things, and then what you used for filtering and why you didn't?
Yeah. So for filtering, we only use GPT-4 because there is just such a gap of intelligence between 3.5 and 4. For data creation, actually, for phie 1.5, we only use GPT 3.5. And for phie 2, we used a little bit GPT-4 also. But there is a lot more, room for improvement just by using GPT-4 for everything. Yes.
You say something, the way I understand is that your team has a certain value framework by which they evaluate these models.
Yes.
We've discovered to our chagrin that some values that may seem obvious, like engagement, aren't necessarily good things for, say, 11-year-olds.
Yes.
What do you think is, or what should be the value creation framework for applying a set of common sense values criteria to these models, and how would that operate within Microsoft? Say, would there be another team that would be evaluating the framework that you would be applying, or how
Yeah.
would this work effectively?
Yeah. So I think about this a lot. Again, my first answer is that I don't want to be the one deciding. I want to say that at the outset. With that being said, there are two things that I'm personally doing very concretely. So one is my team, I think, is very diverse. We have people from all kinds of places, from, India, China, France, Germany, the Commodore, South America, like from everywhere, all kinds of style of representation. It's real. Like it really genuinely makes a difference. Like we're all, watching what everybody else is doing. So that's one important point. The second one is the other answer that was given before, that there is an external body to my team which is checking my work. I'm not allowed to, do whatever I want and then push it into Microsoft products or push it on Hugging Face. Not at all. There is a body which is called the Data Safety Board Review inside Microsoft, but completely external to my organization, which has their set of values following the White House principles, and they check for everything that they have their own red teaming effort. Now, this is within Microsoft, within my team, but there is a discussion at the scale of the world which need to be had. And I think this is one of the points of those meetings, like the one today. Yeah.
I'm Nadia Kawa, the Presidential Innovation Fellow at December. When I look at that graph, I can see that all the blue bars are higher.
Yes.
But I can also see that for some of the demographics, in spite of all the improvements and the efforts, they are still lower, like the women demographic, and that's a large portion of the world population.
It is.
The lowest in terms of toxicity. So do you have any insights as to why?
Or how to overcome it, not why, because it's transformer, how to overcome it.
So, okay, several answers. First one is, I am not fully convinced that you can compare the absolute, scale of these different bar plots. Okay, that's point number one. It could be exactly as you said, because it's a bigger group. Maybe there was a lot more, prompts in there. Some of them being much more difficult, much more tricky. So it's not necessarily that you can compare across those groups. That's point number one. I'm not sure. Okay. Point number two is exactly that this kind of plots puts the emphasis. It says, okay, look, this is where you're doing bad now. So now what you can do with this process is that you can go back to the synthetic data generation, turn the knob in some ways. When I was saying, remember I said in Tiny Stories, you pick 3 words at random. Now, imagine you have male and female. You don't have to do 50-50. You can say, okay, I'm going to sample 70% female and 30% male for the next billion tokens that I want to generate. You can try to do those games and then recompute those things. We've done a lot of it, but obviously it's not perfect yet. And again, and this is PHI 1.5, our next models are better. So what I'm trying to tell you is this is not perfect, but what gives me hope is that now that we have tools to go after it. It's not just, collect data and hope for the best.
So with the knobs you have, you talk about that you can change.
Yeah.
Do you again have any guidance or regulations on, this means I need to adjust this factor to improve that metric? Or is it just randomized? Yeah, let's just try this randomly and look, here's a pattern, follow that because we think it's right.
Yeah, I mean, I think I think everybody knows in this room, like the certainly at the regulatory level, it's not fine-grained like this at all. There's no guidance whatsoever on this. What is put in place are processes. So now, my team itself has their own processes. Then there is a DSB board. Then, when we push it online, if we push it on Hugging Face and it's publicly available and everybody can play with it, we better be pretty comfortable with what we.
But there's no correlative possibility to say, when I turn this to a 3, that changes this to something.
No, the science is not there yet.
All right, thank you.
Unfortunately, I think a lot of us have more questions we'd like to ask. One question that a lot of us would like to ask is when's lunch? And lunch was supposed to be about almost half an hour ago now. And so unfortunately, I have lots of questions that I would like to ask. Maybe we'll just have to bother Sébastien during lunch. And we're gonna try to stay on schedule. So I think when is the next event?
So
2:05?
you can come back by 2:05. So we have box lunches. You can go to the second floor. There's areas over here on the sixth floor. You can stay in here. And walk around the building. But please come back at 2:05 so we can start. Then for
All right.
panel 2.
Yes.
No, we have a long day and we appreciate you sticking around.
Right, let's thank our speaker. Thank you very much, Sébastien, for coming. Your talk was great. So yeah, we're planning to come back at 2:05.
We're in Redmond.
Yes.
I'm sorry.
Oh, nice, nice. Yes, so